Alright, so I know you're thinking, okay, we're spending all this time memorizing the unit circle. You say that you're going to give it to us after we take a quiz on the memorization of it. What's the point of all this? Why do I care so much about this unit circle? What makes it so magical and mythical? Well, it helps us in evaluating trig functions if we're evaluating trig functions at those special angles, which happens quite often. So we have our unit circle with all the angles and all the coordinates. We know how each trig function relates to the unit circle and to the coordinates. So now we're going to use that. So we have evaluating the trig function at an angle. We looked at how to do this on our calculator. So you can do this on the calculator. However, if it is one of your special angles that's on the unit circle, you don't want to waste the time typing things into your calculator, because I'm sure you've noticed already at this point, there's a lot of room for error typing things in your calculator. One, you have to make sure you're in the right mode, then you might have to deal with parentheses, maybe you have to do a reciprocal function which aren't actually in the calculator. So there's a lot of things that could go wrong, whereas if you just look something up on the unit circle, or even better yet, know it, maybe have it memorized, then it's much quicker and easier. So for example, if I want to find what is the value of the sine of 5 pi 6, well, I recognize 5 pi 6 is one of the special angles on my unit circle. So I look at my unit circle. I find 5 pi 6. Okay. How does sine relate to the coordinates on the unit circle? Sine is the y coordinate. What is the y coordinate here? It is 1/2. So the sine of 5 pi 6 is 1/2. What is the cosecant of 315 degrees? Okay, well, I look on my unit circle. Here's 315 degrees. So I'm looking at this point. What is cosecant? Cosecant is 1 over the y value. What is the y value? It's negative root 2 over 2. So I know the cosecant is going to be negative 2 over root 2, because it was 1 over negative root 2 over 2. We want to rationalize this, and I'm not going to show the work, but it's going to come out to be negative root 2. If you're not sure, again, how I'm going from the green to the blue, please talk to me in class, and I will help you with rationalizing radicals in the denominator. Okay, so we've done those two examples together. I want you to try and do the rest on your own. So pause the video, evaluate each trig function at the angle, unpause when you're ready to check your work. Alright, so we should end up with the cosine of 5 pi fourths is negative root 2 over 2. And again, I look at 5 pi fourths, cosine is the x value is negative root 2 over 2. Don't have to do any work. Cotangent of 5 pi thirds. Here we're going to do a little bit of work. So 5 pi thirds is down here. Cotangent is the x coordinate divided by the y coordinate, so 1/2 over negative root 3 over 2. So I do 1/2 over negative root 3 over 2. When I divide fractions, I multiply by the reciprocal of the denominator. So it's negative 1/2 times 2 over root 3. This becomes negative 1 over root 3 because the 2's reduce. And then when I rationalize, I get negative root 3 over 3. So the cotangent of 5 pi thirds is negative root 3 over 3. The secant of 60 degrees. 60 degrees is right here. Secant is 1 over the x value. The x value is 1/2. So 1 over 1/2 is 2. And tangent of 150. 150 is right here. Tangent is y divided by x. So 1/2 over negative root 3 over 2. Whoops. So now, I know it's 1/2 over negative root 3 over 2, but I know that's going to become negative root 3 over 3 because I just did that work up here in a previous problem. So I know the tangent of 150 is negative root 3 over 3. So this is what we mean when we're going to evaluate trig functions using the unit circle, or at the special angles on the unit circle. Again, it's a little bit, hopefully, it should be quicker than a calculator. And what's even nicer is it gives us exact values as well. And another thing to point out is we also evaluated trig functions like this at these special angles, but we always used acute angles before. because then we would draw a triangle. So keep in mind that, for example, 5 pi fourths has a reference angle of pi fourths. So really I'm just using the 45, 45, 90 triangle. The only thing I also want to pay attention to is 5 pi fourths is in the third quadrant. So it's going to have negative sides to the triangle. Remember that we can have negative sides to a triangle when it's representing a location. The actual distance of each side is not negative. But again, this saves us time for not having to draw those triangles now. Alright, so then the other type of problem is again something we've done with the calculator, but now we're going to look at doing it without the calculator if it comes from values on our unit circle at the special angles. So we want to find the angle given the value of the trig function. So find theta in degrees and radians. We have a restriction between 0 and 2 pi for radians. Notice that we are including the 0, but we are not including the 2 pi. And between 0 and 364 degrees, again, notice we're including the 0 and not the 360. It's very important. So take a second and think about why do we need the restrictions on theta, and how many potential answers will there be from the restrictions for each problem. So we've discussed this a little in the past, but take a second, think about it yourself, pause the video, write down some thoughts, unpause when you're ready to discuss. Okay, so why do we need the restrictions on theta? Well, we talked about this before when we were doing these problems on our calculator, and we actually had a more strict restriction. We were only going between 0 and pi halves and 0 and 90 degrees. So here we're doing one lap on the circle. Basically, that's what these restrictions are telling us. And because 0 and 2 pi are coterminal angles, we're only going to count that once. So we're going to count the 0. And same with the 0 and 360. Those are coterminal angles. So we're only going to count the 0. We're not going to count the 360. So why do we need those restrictions, though? Because otherwise, we would have an infinite amount of answers. There's an infinite amount of coterminal angles. So there are infinite coterminal angles that will provide the same value for a given trig function. So then the next question is, how many potential answers will there be from the restrictions for each problem? Well, at most, there's 2 locations within each of those restrictions where a given trig function will have that value, at most. So if there's 2 locations, because we're answering in both radians and degrees, there would be 4 answers, because we would have 2 radian answers and 2 degree answers. So let's go ahead and do some of these problems then. So the sine of theta equals negative root 3 over 2. What is that saying? That is saying, on the unit circle, where does sine equal negative root 3 over 2? So we're looking for the angle now. Negative root 3 over 2 is the coordinate, or the ratio of sides of triangles. So sine is the y value. So all we're doing is looking, where is the y coordinate, negative root 3 over 2. There's 2 locations. I have it here at 5 pi thirds, which is also 300 degrees, and I have it here at 4 pi thirds, which is 240 degrees. So there are the 4 answers, but they're really only representing 2 unique locations within this restriction. So now I want you to try and do the remaining 3. So pause the video, try those, unpause when you're ready to check your work or when you get stuck. All of these answers are possible from the unit circle, by the way. Go ahead and pause. Okay, so let's talk about the cotangent first. So if cotangent of theta equals negative 1, what does that tell me? Well, I know that cotangent is the x-coordinate divided by the y-coordinate. So if I divide any 2 numbers and I get a negative 1 as a result, what do I know about those 2 numbers? I know that they had to be equal, so they had to be the same numbers, but opposite signs. So one of them has to be negative and one of them has to be positive, but they're the same numerical value. The absolute value is the same. So where does that occur? So I look on my unit circle, where are x and y the same but opposite signs? That's here at 3 pi fourths and at 7 pi fourths. Because here x is negative root 2 over 2 and y is root 2 over 2. Here x is root 2 over 2 and y is negative root 2 over 2. So if I divide those, I will get negative 1. So I have 3 pi fourths, 7 pi fourths, or 135 degrees and 315 degrees. Where is secant going to equal 2? Well, I know secant is the reciprocal of the x value. So if the secant equals 2, then x has to equal 1/2, because the reciprocal of 2 is 1 over 2, and vice versa. So where does x equal 1/2? That's at pi thirds and 60 degrees, and 5 pi thirds and 300 degrees. So my answers are pi thirds, 5 pi thirds, 60 degrees, and 300 degrees. Where is the cosecant of theta undefined? What does that mean? Undefined is not a value on the unit circle. Well, what makes something undefined? Well, it's undefined if I divide by 0, because I can't divide by 0. That is not a defined value. Isn't it great how all this math vocab just keeps coming back? So we're dealing with cosecant, and then you know cosecant is 1 over the y coordinate. So if the y coordinate is 0, then the cosecant of theta will be undefined. So where is the y coordinate 0? It's at 0 and 180. So cosecant of theta is undefined at 0 and pi radians, or 0 degrees and 180 degrees. Okay, so these skills right here, using the unit circle to evaluate trig functions at the special angles on the unit circle, and finding the angle, knowing the value of a trig function and knowing that it's on the unit circle, these are two skills that are going to be incredibly important throughout the rest of the semester. They'll also be very important when you have calculus next year. So understanding how to use the unit circle is essential to success in here. So really try to focus on understanding and paying attention to how do I find these answers effectively and efficiently. Because as you see from most of these problems, there's not a ton of work involved. It's really just looking something up, but if you don't know where to look and what you're looking for, then it becomes difficult.